All right, hello everybody, this is Ms. Piekarski. I'm doing the first recording of Unit 7-1, and it's all about polynomial functions. I should caution you, one of my classes is taking their test right now, so if there's any background noise, it's all them. None of it's me. Okay. In fact, if Miracle makes a really loud noise, you can all make fun of her tomorrow, tell her you heard her in the video. Okay. So let's go ahead and get started. This unit is all about polynomial functions. You need to find this somewhere in your notes. We are going to be hopping around the notes a little bit today, and we're not going to go over all the vocabulary terms, just some of the basics that you should already know. All right, so you've seen polynomial functions before, and this is a big, long definition of it, and it probably doesn't make a whole lot of sense. There are some things that you need to write down on your paper and fill out. I think all the bold words are the ones that you need to write down. So let's go ahead and read that, and then I'll explain what it means. All right, so essentially a polynomial function is the sum or difference of terms that have variables raised to positive integer powers, basically your exponents, and which have coefficients, so numbers in front of the variables, that may be real or complex in a polynomial function. Variables are not in a denominator, under a square root symbol, or in the exponent. Okay, so these are all different types of other types of functions. So you're not going to see the square root symbol. You're not going to have your variables in the denominator, and you also will not have any variables in your exponents. Okay, in general, polynomials can be written as f of x equals c sub n, x raised to the n power, plus all this stuff. I'm not going to read the whole thing out. It looks really confusing up here, and you probably are thinking you've never seen this before. You have, just it doesn't look like all this extra mess, okay? Basically, your C's are your constant terms, and this is your first constant term, your second constant term, your third constant term, and so on. Where C of k represents any real number or constant, and n must be a whole number. Okay, so that may not make a whole lot of sense to you, all this big long definition. Let's look at some examples, and you're probably going to be like, oh, I've seen those before. Okay, so basically the w of x, here's one polynomial. Okay, notice that you have constant terms to some number in front of your variable x, and each one of these x's has an exponent. Okay, so you have a 4, a 3, a 2, and most of you are going to say, hey, this one does not have an exponent. Well, it actually does. The exponent is 1, but if it has an exponent of 1, you don't have to put it up there. In fact, it's standard practice not to put the 1 there. So just remember, even if it doesn't have an exponent there, the exponent is 1. Now this one is also has an x, but this x is raised to the 0 power. So you have 4, 3, 2, 1, and 0. Okay. Now, the reason why it's not shown up there is because x, or anything raised to the 0 power, is always going to equal 1. Okay, so it's standard practice not to, you don't have to write this here. All right, these are all going to be different examples of polynomials. You do not need to write them down. I just want you to see them and recognize them and know that these are all polynomials. Okay, notice we have a fraction here, and that's fine as long as the x is not in the denominator. Okay, let's move on to some of our other vocabulary terms. Okay, your constant term is the term in an algebraic equation which contains no variables, absolutely no variables. Okay, and essentially that's where your x is raised to the 0 power. Okay, and that's why it's called a constant term, because the x does not affect it at all. All right. So there's no variables. If there is no such term, the constant term is 0. Okay, here's two examples. Okay, here's two examples. This one, the exponent is 2, the exponent is 1 here, and this one is your constant term. Now notice this one, you do not have a +1 or +2 or plus anything else, so your constant term is 0. Okay, a cubic function, you've seen them before, a polynomial of degree 3. What that means is the highest exponent is a 3. Okay, the degrees are just that's a term to describe the highest exponent used in a polynomial function. What amazes me is that these terms are all in alphabetical order, but some of the terms, like degree, is used in the definition of other terms. Anyway, so just when you say what's the degree of the polynomial, they just want to know what is the highest exponent. So let's look at some examples in this one. Your degree is 2. In this one, your degree is 7. Notice that usually your polynomials or your exponents are in descending order. So 2, 1, 0, 2, 1. This one has a degree of 2, an exponent of 1, and an exponent of 0. So usually they're in descending order, but sometimes they're not. In this case, this one has the x raised to the 7th power at the end. Okay, it's perfectly fine. Your exponent is 4 here. Now this one, it doesn't look like either of those have exponents, but again, if they don't have an exponent shown, then the exponent is 1. This one here, again, your exponent is 1, and this one, the degree is 0. Okay, hopefully you understand that. It shouldn't be too hard. All right, so we've seen coefficients before. Coefficients are the numbers that are in front of your exponent. So in this example, it's this one. This is a coefficient. Let me see, there's a coefficient there. There's a coefficient. There's a coefficient. So there's lots and lots of different coefficients that you've already seen before. Those are all coefficients. Okay, now the leading coefficient is the constant term or number that is multiplied to the variable with the greatest degree. Okay, so in this case, your leading coefficient would be this one, and notice you don't have a number there, so the leading coefficient is 1. In this case, your leading coefficient is 5. Here, your coefficient is 1 as well. Here, it's the 2 and the 3. Okay, with this one, even though the x raised to the 7th power is last, the leading coefficient is still right here. It's the 1. Okay. In this example here, your leading coefficient is -2. Right here. All right, sorry, student had a question. All right, last couple of terms we want to look at, maximum value and minimum value. The maximum value is the highest point over the entire domain of the function. So this point right here would be the maximum value. A relative maximum is the highest point in a particular section. So this one is a relative maximum. So from like here to here, the highest point is here. Okay. Same thing with minimum values. You've seen them before. Minimum values here and here and here. And I think that's all. Wait, no. We have, a couple more definitions I want to go over. Quadratic polynomial functions and quartic polynomial functions. This one's second degree polynomial, the degree of the polynomial is 4. So these are just examples of your quadratic. Your degree is 2, and quartic is 4. All right, that's the end of the notes that we're going to discuss today. We'll go over the rest of the notes later on. All right, talk to you later. Bye.